Good morning. Today we can discuss about the DC chopper circuit part 2. In previous video we can discuss about the DC chopper circuit part 1. In part 1 we can discuss about that basic configuration of DC chopper circuit and the classification of DC chopper. Dear my students, we all know that DC chopper circuit can be classified that in three different ways. First one, buck converter, second one, boost converter, and third one is the combination of buck and boost converter. Dear my students, we know that DC chopper circuit is nothing but it can be convert the fixed input voltage into variable DC voltage, right? Now that we can categorize the three different DC chopper. In case of the boost converter, if the output voltage can be increased from the input voltage, so that type of the DC chopper circuit is known as a boost converter, otherwise step up chopper. In step down chopper, if the output voltage can be goes into the lower value than input voltage, right? So that in this video lecture we can discuss about this step up chopper, means output voltage is greater than input voltage. This type of the chopper circuit is known as a boost chopper circuit, otherwise it is also known as a step up chopper. Now the basic step up chopper circuit, so that in figure A we can draw the basic step up chopper circuit. In case of the step down or a boost converter, we can put the switch as is series with the input source. Now here we can replace the switch is parallel with the input source. Now that switch can be goes into the either turn on condition or a turn off condition. Depending on the position of switch S, the diode can be goes into the forward bias or a reverse bias. Dear my students, we all know about that forward bias condition of diode as well as the reverse bias of condition of diode. If P region of diode is connected the P terminal of battery and N region of diode is connected the negative terminal of battery, so that connection is known as a forward bias connection. In case of the forward bias, that can be work as a closed switch. If the polarity will be reverse, so that can be work as a reverse bias condition, and that can be goes into the turn off condition. So figure 2, that is the equivalent circuit of on state. Figure 1 is the basic step up chopper circuit, and in case of the figure 2, that is a equivalent circuit of on state. That means a switch can be goes into the turn on condition. Now switch can be goes into the turn on condition, so that diode will be goes into the reverse bias condition, so that can be work as a open switch. And figure 3, that switch can be goes into the off condition, so diode can be goes into the forward bias condition, so that can be goes into the closed switch. So that is equivalent circuit for the off state, and figure 2, that is equivalent circuit of the on state of basic step up chopper circuit. Now that figure 2 and figure 3, figure 2 that is our on state and figure 3 that is our off state, right? So that when in on state, when S is on, that means the switch is goes into the turn on condition while diode is goes into the turn off condition, so that capacitor energy supply the load voltage. So we are getting the output voltage equal to output of VC. VC means the capacitor charging voltage. So output voltage equal to VC, right? While we can discuss about the off step, when S is goes into the off condition, right? So inductor voltage reverse its polarity and add the input voltage to provide the output voltage. So which is equal to that output voltage V out equal to input voltage Vi plus voltage across the inductor, that is known as a VL. So that output voltage V out equal to Vi plus VL, that can be goes into the off condition, while similar way that can be goes into the on condition, V out equal to Vc, right? Now in case of the on state, during the on state of switch S, the voltage across inductor that become equal to the input supply voltage. Current through it can be increased gradually and store energy in magnetic fields. For very first time when S is closed, so output voltage equal to 0 and capacitor is not charged. During off state of S, the capacitor charge and voltage is gradually build up Vi plus VL, right, dear my friends? So if in case of the off state, if S is off forever, the inductor act as a short circuit. It does not develop the any voltage, so that output voltage Vi equal to Vi. If the inductor can be generate the voltage, so that output voltage is V out equal to Vi plus VL in case of the off state. So that dear my student, now we can clear about that what is the output voltage. In on state, output voltage is equal to Vc, means that is a voltage across the capacitor, and in off state output voltage equal to Vi plus VL. Now if we are considering the duty cycle is 50%, dear my students, we all know that what is a duty cycle. It is a ratio of T on divided by the total time period. Now duty cycle is 50%, that means we are counting the T on period is 50%, right? So we are calculating the D equal to 0.5, means switch is on and off for the equal time interval, right? On period as well as the off period, both are the equal. So in waveform we can see that positive half cycle, otherwise that switch can be goes into the closed condition, that can be represented as S on, and in negative half cycle that switch can be goes into the turn off condition, so that polarity of diode will be reversed, so it can be goes into the on condition, so it can be represented as a D on condition, right? So both are the repeatedly, because of the we can designing this waveform by using a duty cycle is 50%. Now energy that inductor developed during on state is completely dissipated during the off state, because of the both the duty cycle are same, 50% on state and off state both are the same. So those energy can be developed during the on state, that will be completely dissipated by the inductor during the off state. If the duty cycle is increased above the 0.5, inductor will not be dissipate the energy completely in off state. The remaining inductor voltage add up for the next time when the switch is off, and more increased voltage appearing at the output voltage, right? So we can see the different output waveform. Capacitor voltage across the that can be represented as IC, and it can be seen that that is our waveform number 5, right? And finally in last we can generate the output V out, and the V out can be goes by switch close and switch open circuit. That now if the duty cycle is increased above 0.5, so inductor will not dissipate the energy completely in off step, right? So remaining inductor voltage add for the next time when the switch is off, and more increase the output voltage as the output side, right? So dear my students, if we can neglect the loss, the energy transfer by inductance during T off must be equal to the energy gain by its during the period T on. So that finally expression for the output voltage is V out equal to Vi into inside the bracket 1 divided by 1 minus D. That is our equation number 1. If the switch is open condition, that means D equal to 0. So output voltage is equal to the input voltage. In equation number 1 we can replace the D is 0, right? So we are getting the V out equal to Vi, so that output voltage is equal to the input voltage. If we can increase the D, so output voltage become larger than input voltage, so that output voltage is always higher than input voltage if the switch is operating approximately higher frequency. If the output voltage is always larger than input voltage, so that type of the chopper circuit is known as a step up or boost converter, right? So dear my friends, now the application of step up chopper. So it can be used commonly as a LED drivers. Step up chopper is also used for the solar power system. It is also used for the power factor correction, used for the HVDC system, and most it can be applicable for the utilization in hybrid electrical vehicle. Now students, last and important, that is our buck and boost chopper. That means it is a combination of buck as well as the boost chopper. So now we can clear about that, how that buck converter can be work, otherwise step up chopper can be work, or a step down chopper can be work. So in case of the buck converter, otherwise step down chopper, so output voltage is smaller than input voltage, so that type of the chopper circuit is known as a step down chopper. If output voltage is greater than input voltage, so it is known as a boost chopper circuit. So now it is a combination of both buck as well as the boost, otherwise step up or step down. So that buck and boost converter is a type of DC to DC converter that has the output voltage magnitude that is either greater than or less than of input voltage, is known as a buck boost chopper. If D is greater than 0.5, then output voltage is higher, so that can be work as a step up chopper. If D is less than 0.5, then output is lower voltage, so that can be work as a step down chopper circuit. So that figure A is the basic buck boost chopper circuit. So here we have to connect the series switch S with that input voltage supply Vi, and the inductor is connected with the parallel with the input voltage Vi, right? So that switch can be operated in two different mode, either turn on condition or a turn off condition. If the switch can be goes into the closed condition, right? Switch can be closed into the closed condition, so that input voltage source Vi is directly connected with the inductor VL, and diode can be goes into the reverse bias condition, so that can be work as a open switch, and that can be represented as a figure V. That is the equivalent circuit of on state, right? In case of the figure 3, if the switch can be goes into the open condition, so that input is not directly connected with that inductance, right? So that diode can be connected with the forward bias condition. In case of the forward bias, that can be work as a closed switch, so that can be goes into the equivalent circuit of off state, right? So figure 2 is the on state and figure 3 is the off state of buck and boost DC chopper circuit. So that in that is output waveform of a combination of buck and boost waveform. Here we can also designing this waveform by using a duty cycle is 0.5. That means on period as well as the off period both are the same. So switch is closed and switch is open, both are the same with equal interval of time. So energy that inductor developed during the on state is completely dissipated during the off state, right? If the duty cycle is increased above the 0.5, the inductor will not dissipate the energy completely in off state, right? And the remaining inductor voltage that can be added up the next time when switch is off, and more increase output voltage at the on times, right? So that application of buck and boost converter, that is it can be used for the regulated DC power supply. It can be also utilized in DC motor drive, control circuit, electrical automobiles, and telecommunication power supply, right? So dear my friends, now we can clear about that how that step up chopper can be work, step down chopper can be work, and the combination of step up and step down chopper circuit. Thank you.